This video contains the solutions to sample exam number 1. For this first problem, we're given a function and we're asked for f of negative 10. And so what we need to do is take the expression for f of x and substitute in negative 10 everywhere we see an x. And we just have to be really careful with the parentheses here. Remember that as a general rule, whenever you substitute into a function, the thing that you're substituting in you should put in parentheses. So in this case we have negative 10 squared, which is positive 100. 13 times negative 10 is negative 130, minus 4. So that's minus 100, minus 130, minus 4. That's negative 234. Here we want a formula for a linear function such that f of negative 7 is negative 12 and f of negative 4 is 3. So remember that whenever we see an expression like this, f of negative 7 equals negative 12, this means when x is negative 7, y is negative 12. Or in other words, we just have the point negative 7, negative 12. Similarly, f of negative 4 equals 3 tells me that I have a point negative 4, comma 3. And now we realize that we're just being asked for the equation of a line given 2 points. So the first thing we need to do is find the slope. The slope is y2 minus y1 divided by x2 minus x1. y2 is negative 12, y1 is positive 3, x2 is negative 7, and x1 is negative 4. Again, being really careful with our minus signs, we get negative 15 on the top and negative 3 on the bottom. That gives us positive 5. Now using our point slope form, y minus y0 equals mx minus x0. We know the m is 5, and we can use either one of these points for the x0 and y0. I'll use the point negative 4, comma 3. So my x0 is negative 4, and my y0 is 3. So I get y minus 3 equals 5x plus 20. Add 3 to both sides. I get y equals 5x plus 23. This time we're given a linear function, and we want to find the x and y-intercepts. So again, remember that f of x is really just another name for y. So this is y equals 2x minus 2. The x-intercept is where y equals 0. And the y-intercept is where x equals 0. So for the x-intercept, we're going to replace the y in the equation with 0 and solve for x. Add 2 to both sides, divide both sides by 2, I get x equals 1. So the x-intercept is the point 1, comma 0. And then similarly for the y-intercept, I replace x by 0, so I get 2 times 0 minus 2. That gives me y equals negative 2. So the y-intercept is 0, comma negative 2. And those are my two answers. Next up we have a problem involving revenue and cost, and we're asked to find the break-even point where revenue equals cost. We're told that revenue is 7x, and cost is 5x plus 36. So solving for x, we get 2x equals 36, or x equals 18. The break-even point is a point, which means that we need to take this x and plug it back into either one of these functions. We're going to get the same answer no matter which one we plug into. So let's just plug into the r function, since that's a little bit easier to plug into. So r of 18 is 7 times 18, which is 126. So the break-even point is 18, comma 126. Here we have to solve the equation. We've got to distribute on the left and the right, so we get 2t plus 20 equals 3t plus 18. Subtract 3t from both sides. That gives me negative t. Subtract 20 from both sides. That gives me equals negative 2. Negate both sides, we get t equals 2. Another equation to solve, this one involving fractions. So my advice with an equation like this is to multiply both sides by something that will get rid of the fractions. In this case, since my denominators are 3 and 2, a common denominator that will get rid of both fractions is 6. So on the left-hand side, 6 and 3 divide out, just leaving 2. And on the right-hand side, 2 and 6 divide out, leaving 3. So that gets me 2 times the quantity t plus 2 equals t plus 3 times 3. That's 2t plus 4 equals 3t plus 9. Subtract 2t from both sides, subtract 9 from both sides, and I get t equals negative 5. Here we have a graph of a function, and we're asked to evaluate f of 3. So this just means what is y when x is 3. So on our graph, we find 3 on the x-axis, and we look up and down to try to find where the function is, and we see that it's right here at this point, and this is the point 3 comma 5. So that means that f of 3 is 5. Same graph, now we're asked how many solutions does the equation f of x equals 0 have? And another way to think about what this is asking is, for how many points on this graph does y equal 0? And if you're only paying attention to the big dots, it looks like the answer might be none. But remember that all of the lines connecting those dots, those are part of the graph as well. And so we can see that we've got a point here where y equals 0, and another point here where y equals 0. And that means that the answer is 2. Another equation of a line problem. This time we're given a slope and a point, so we can go straight to our point-slope form. Y minus y0 equals mx minus x0. So that's going to be y minus negative 2 equals m times x minus negative 9. That gives us y plus 2. That's x plus 9 in the parentheses, so this is 2x plus 18. Subtract 2 from both sides, we get y equals 2x plus 16. For this one, we want the equation of the line that's perpendicular to negative 2x plus 5y equals 3, passing through the point 1 comma 0. So the hard part of this one is going to be figuring out the slope of the line that we want. And the first thing we'll need to do is find the slope of the line that they gave us. Because negative 2x plus 5y equals 3 is not in slope-intercept form, which means it's hard for us to immediately see what the slope is. We've got to solve for y. So let's add 2x to both sides. We get 5y equals 2x plus 3. Divide both sides by 5. We get 2x plus 3 over 5. And now we're going to rewrite that as 2/5 x plus 3/5. And that means that the slope of the line they gave us is 2/5. And since the line we want is perpendicular to that line, the slope of the line that we want is the negative reciprocal of 2/5, namely negative 5 over 2. And now that we know the slope of the line, and we have a point that the line should go through, we can use our point-slope form. Y minus y0 equals m times x minus x0. Our line has slope negative 5/2, the x0 is 1, and the y0 is 0. So distributing, we get y equals negative 5 over 2x plus 5 over 2. Here we're given a function that tells us the cost of a call in terms of the number of minutes. So c of x is equal to 0.26x plus 5, where x is the length of the call in minutes. So what is the cost of a 10-minute call? Well, x is the length of the call, and they tell us that the call is 10 minutes long, and they're asking what is the cost. So they're telling us what is c of 10. So c of 10 is going to be 0.26 times 10 plus 5. That's 2.6 plus 5, that's 7.6. And since we're dealing with cost, dollars and cents, we're going to use 2 decimal places, so we get $7.60. Same function here, and now we're told that the cost is $8.90, and we want to know how long was the call. So in other words, we want to know what is x when the cost is 8.90. So we're going to set cost, which is 0.26x plus 5. We're going to set that equal to 8.90 and solve for x. Subtract 5 from both sides, we get 3.90. And divide both sides by 0.26, that's going to give us 15. X is the length of the call, so the units here would be minutes. Now we have a mixture problem. We have a mixture of water and antifreeze that is 60% water, and we want to add 0.4 gallons of water to that, and we find out that the mixture becomes 70% water, and we want to know the original volume of the mixture. So the way that I recommend that you work these out is to make a chart that indicates before and after, because we want to understand the state of the mixture before we added the water, and also the state after we added the water. Since it's a mixture of water and antifreeze, I'll have a column for water, I have a column for antifreeze, and then I'll have the mixture of the two. The total volume of the mixture is what I want to know. And remember, what we want to write in the chart is amounts. Don't write percentages in the chart, write amounts in the chart. In this case, that's volumes. In other words, amounts of gallons. So I don't know what the volume of the mixture was before, but I do know that the mixture was 60% water. So whatever that volume was, 60% of that volume is water, and that means that 40% of that volume was antifreeze. I didn't add any antifreeze, so the volume of antifreeze after is the same as the volume before. But I added 0.4 gallons of water, so that means that I added 0.4 to my volume of water. And since I added 0.4 to the mixture itself, the volume of the whole mixture is also x plus 0.4. Now there's a couple different ways that I could proceed here, but I know that the mixture is 70% water. So this water amount, this is 70% of the total. And that means that my equation is that 0.6x plus 0.4 equals 0.7 times the total volume, x plus 0.4. And now we'll solve. So distributing on the right-hand side, we get 0.7x. 0.7 times 0.4 turns out to be 0.28. Subtract 0.6x from both sides, that gives us 0.1x. Subtract 0.28 from both sides, that's going to give us 0.12. And that means when we divide by 0.1, we get x equals 1.2, and the units here would be gallons. Here again we have a mixture problem, this one involving per unit price. So we've got a mixture of cashews and pecans, and we want to, and actually there's a typo here, that should just be cashews and almonds. We want to sell the mixture for $6 a pound, cashews sell for $8 a pound, and almonds sell for $5.50 per pound. And we want 40 total pounds of the mixture. So the way that we want to start setting this up is to realize that the cost of the cashews plus the cost of the almonds equals the cost of the mixture. And the cost of the cashews is a product. It's the cost per pound of the cashews multiplied by the number of pounds of cashews. If I know how much each pound costs and I know how many pounds I have, I multiply those together to get the total cost. And I'm going to do that for almonds, and I'm going to do that for the mixture as well. Each of these is the cost per pound times the number of pounds. Now, a lot of this information we can fill in just by reading the problem. Cashews sell for $8 per pound, so 8 goes there. Almonds sell for $5.50 a pound, so 5.50 goes there. The cost per pound of the mixture is supposed to be $6 per pound. We want the mixture to cost 6, and we also know that we want 40 pounds of the total mixture, so 40 is going to go there. Now what we don't want to know is, what we don't know yet is the number of pounds of cashews and the number of pounds of almonds. So we can call the number of pounds of cashews x, but we want to hesitate. We don't want to call the number of pounds of almonds. We don't want to call that y, because that will give us an equation with 2 variables and we won't be able to solve that. So what we have to realize is that since we have x pounds of cashews and 40 pounds total, then the number of pounds of almonds is going to have to be 40 minus x. In other words, if I had, say, 10 pounds of cashews, I would have to have 30 pounds of almonds to make the total of 40. If I had 25 pounds of cashews, I would have to have 15, 40 minus 25 is 15, to make up to for the total of 40. So this gives me my equation to solve. So I get 8 times x plus 5.50 times 40 minus x, and 6 times 40 is 240. So we start working this out. 5.50 times 40 minus 5.50 times x. So 8 minus 5.5, that's 2.5, so 2.5x. 5.5 times 40, that's 220. So we get 2.5x equals 20. Divide both sides by 2.5, and that gives us 8. So that means we have 8 pounds of cashews. Remember, that's what x stood for. And then how many pounds of almonds? Well, that was 40 minus x. So if x is 8, 40 minus x is 32. And that tells me how many pounds of almonds we have. All right, so now we've got some data points, and we've been given a graph of those data points, and we're trying to find two of the data points so that when we draw the line connecting those points, that fits the line as well as possible. So we want to pick 2 points, and then we're going to find the equation of the line that connects those 2 points. And there's lots of valid choices here, so there's not going to be one right answer to this question. There's going to be lots of right answers, but there are going to be some wrong answers. So let me just sort of illustrate a couple of the answers that we wouldn't want to pick. So for example, we would not want to pick this point and this point, because if I draw the line that connects those 2 points, that line doesn't really come very close to connecting the rest of the points in my data set. So that's really not a good choice here. Another bad choice might be this point and this point, because again, if I draw the line connecting those points, it comes pretty close to that point on the right, but it goes well below all of the other points in my data set. So again, not a very good choice. But beyond that, there are a lot of good choices. So again, I'm just going to pick a couple of points here that make a reasonable choice, and if the pair that you're thinking of is slightly different, then you might get a slightly different answer. But I'm going to pick this point and this point, because again, if I draw the line connecting those points, what I can see is that it does a pretty good job of going through or close to the rest of the points in my data set. Now I have to figure out which 2 points did I actually just choose. So the first point I chose, the x-coordinate is between 60 and 70, so that must be this point here, 65, 1140. And the second point I chose, that x-coordinate is between 90 and 100, so that must mean I chose this point, 95, 730. And now that I've chosen the 2 points, all I have to do is find the equation of the line connecting these 2 points, which is a problem we've done several times before. Okay, so the 2 points we picked were 65, 1140, and 95, 730. So we find the slope between these 2 points, which is the change in y over the change in x, 730 minus 1140, divided by 95 minus 65. 730 minus 1140 works out to be negative 410, and on the bottom we get positive 30, so that's negative 41 over 3 when we reduce. Now I use my point slope form, y equals y minus y0 equals m times x minus x0. My slope is negative 41 over 3. I'll go ahead and use the first point here, although you could just as easily use the second point. So x minus 65 there, and y minus 1140 here. So I'm going to distribute on the right-hand side. I get negative 41 over 3x. Minus times a minus is a plus. And when I multiply 65 times 41 over 3, you can think of 65 as 65 over 1 if you like. 65 times 41 turns out to be 2665, so that's 2665 over 3. I'm going to add 1140 to both sides, but 1140 is, when I write that over 3, is going to be 3420. So I get y equals negative 41 over 3. And when I write 2665 plus 3420, that works out to be 6085. So 6085 divided by 3. And that's the equation of my line.